Have you ever noticed how programming languages have all these different ways of like organizing information? It's like they each have their own systems.
Yeah, like tools for different jobs.
Exactly. And today we're diving into one of those tools in Python. We're talking about tuples.
Ah, tuples. Interesting choice.
So to kick things off, what exactly are tuples in the world of Python?
Well, imagine a list, but with one big catch.
Yeah.
Once you create a tuple, you can't change it.
Oh, wow. Okay, so it's like that friend who's super reliable, maybe a little set in their ways.
Exactly. And in programming, that can be a really good thing.
How so? Why would I want my code to be like stuck in its ways?
Think about it this way. Let's say you're working with data that shouldn't change.
Like what?
Mhm.
Give me an example.
Sure, imagine you have a program that deals with the days of the week. Those days are always going to be the same, right?
Right.
A tuple lets you represent that kind of unchanging data in a way that's both clear and secure.
So it's about ensuring that some things in your code just never change, no matter what. That makes sense. And our sources call this immutability, right?
Spot on. Immutability is the cornerstone of tuples.
So we've established that tuples are like the rock-solid foundation of our data in Python. How do we actually create one? What's the secret handshake?
You remember how we use square brackets to create lists?
Yeah.
Well, tuples like to keep things interesting by using parentheses instead.
Parentheses. Okay, so it's like a subtle signal to Python that we're dealing with something different here.
Precisely. That one small change in punctuation makes all the difference.
It's amazing how much meaning those little symbols have in programming, right?
Absolutely. And when it comes to tuples, that difference in punctuation is key to understanding how Python interprets and manages your data.
Okay, I'm starting to see how this works. But our sources also mention a bunch of methods that just don't work with tuples. Something about them being, like, off limits.
Ah, yes. Because tuples are immutable,
Mm.
any methods that try to modify the tuple directly are a no-go.
So it's like trying to rearrange the furniture in a room that's bolted down.
Exactly. You just can't do it.
So no adding or removing things from a tuple once it's set. That makes sense, I guess. But if
Yeah.
we can't change anything in a tuple once it's made, what can we do with them?
That's a great question. And the answer is quite a bit, actually. It's just a matter of shifting our perspective a bit. Instead of thinking about changing the tuple itself, think about accessing and analyzing the data it holds.
Okay, I think I'm starting to see where you're going with this.
It's like imagine you have a display case full of, say, antique coins.
I like that. A little treasure chest of data?
Exactly. You can't just open the case and swap out the coins, but you can still learn a lot about them.
Right, like how many coins are in there, or what year they're from, that sort of thing.
Precisely. And Python gives us the tools to do that with tuples.
Okay, so what are some of these tools? Walk me through it.
Well, let's start with something simple, finding out how many elements are in our tuple.
Kind of like counting how many coins are in that display case right now.
Exactly. And for that, we use the trusty len function, just like with lists.
So if my tuple was called coins, I'd use len coins to get the total count.
You got it. Now, what if you want to know if a specific coin is in the display case? Say, a rare 1909-VDB Lincoln cent.
Ooh, that's a good one. So how do I check if my tuple contains a particular value?
Python makes this super easy with the in keyword.
In! It sounds almost too simple.
Don't let the simplicity fool you. It's super powerful. You can literally ask Python, hey, is this value in my tuple?
So I could write something like 1909 in coins, and Python would tell me if a coin from that year is in there.
Precisely. It would give you a true or false answer.
That's handy. So we can find out how many elements are in a tuple, and we can check if a specific value is present.
We're on a roll. But there's more. What if you wanted to find the exact position of that 1909-VDB Lincoln cent in the display case?
Oh, that's a good one. Like, is it the third coin from the left or the 10th?
You're thinking like a true programmer. And yes, Python has a way to do that too.
I'm guessing it's not as simple as just asking, where's the coin?
You're right. We need to use something called the index.
Index, like an index in a book.
Exactly. Every element in a tuple has an index, which is just its position in the sequence.
And Python starts counting at 0, right? So the first element has an index of 0, the second has an index of 1, and so on.
You're getting it. So to find the index of a specific value in a tuple, we use the .index method.
Interesting. So if I wanted to find the index of the 1909 coin in our coins tuple,
You'd write something like coins.index 1909, and Python would tell you its position or index within the tuple.
that's cool, but what if the value isn't in the tuple? What happens then?
That's a great question. And it's something to be aware of if you try to get the index of a value that doesn't exist in the tuple.
It's like asking for a coin that isn't in the display case.
Precisely. Python throws what we call an exception. Basically, it raises an error.
So it's always a good idea to first check if the value exists in the tuple using a tup before trying to get its index.
Absolutely. It's all about writing robust code that can handle those unexpected situations.
Okay, so we've covered len, in, and index. Is there anything else we can do with tuples?
Absolutely. There's one more handy method we haven't talked about yet. That count.
Dot count. What does that one do?
It does exactly what its name suggests. It counts how many times a specific value appears within a tuple.
Oh, that's useful. So if I had a tuple of, say, exam scores and wanted to know how many students got a perfect score.
You could use .count to find out.
Yeah.
Let's say your tuple is called scores.
Okay, so I'd use scores.count to count how many times the value 100 appears in the tuple.
Exactly. And just like that, you have a quick way to analyze your data and gain insights.
Wow. We've covered a lot of ground here. It's like we've gone from thinking about tuples as these rigid, unchanging structures to realizing that we can actually do quite a bit with them.
And we've only just begun to scratch the surface. There's more. We talked about how tuples are immutable, and you even compared them to, like, a display case that you can't change, remember?
Yeah, I remember those antique coins all locked up tight.
Well, that immutability is actually a superpower when it comes to certain tasks in Python.
Oh, a superpower, you say? I'm intrigued. Tell me more.
It's all about how Python handles memory and optimizes things behind the scenes.
Okay, you know I love those behind-the-scenes peeks.
Right. So when Python knows that a piece of data can't change because it's in a tuple, it can sometimes store and access that data more efficiently.
So it's like if Python knows the display case is permanently shut, it can build a more efficient system for keeping track of what's inside.
Exactly. It's a bit of a simplification, but you've got the right idea.
That's pretty cool. I always thought flexibility was the key to writing efficient code.
It often is.
Mhm.
But in some cases, those limitations, those constraints, can actually work in your favor. It's about knowing the right tool for the job. And sometimes that tool is a good, old-fashioned, unchanging tuple.
This has been fascinating. We've gone from thinking about tuples as simple containers to understanding how their immutability can actually make our Python code faster.
And we've only scratched the surface. There's a whole world of Python out there, and tuples play a crucial role in many aspects of it.
We could probably do a whole other episode on just the nuances of tuples.
Easily. But for now, I think we've given our listeners a lot to chew on.
Absolutely. We've explored what tuples are, how to use them, why you'd choose them, and even how they can make your code more efficient.
And who knows, maybe we'll revisit tuples again in a future episode.
Hmm.
But until then, keep experimenting, keep coding, and keep exploring the amazing world of Python.
And listeners, if you come up with any creative uses for tuples in your own projects, we'd love to hear about them.
Absolutely. Share your discoveries because there's always more to learn.
That's a wrap on today's deep dive into Python tuples. Until next time, happy coding.